So in our initial check, we found 100 models which were malicious, like really malicious, like I had malicious code in them in Hugging Face. It really looked like someone is trying to hijack machines from that model. The fourth thing is just that talk to your CISO and make them understand that if someone takes over your MLOps platform, it could be the same as taking over your domain controller. Right now, everything is breached. Nobody knows that these attacks are possible.
That was an eye-opener.
I guess the scary thing is because it's vulnerability in the format type, there's never going to be a CVE about this because there's nothing to fix. This is the feature. This is the way it works. So there won't be a CVE. There won't be a patch. Either you know about this issue or you don't.
Hello everyone, I'm Aseem Jakhar, founder of Exploity, and today we are going to be talking about security of machine learning platforms. And I have with me Shachar Menashe, Senior Director, Security Research at JFrog.
Hi.
Let's first start with your current research on the security and attack surface of MLOps or machine learning platforms.
So what we set out to research, like the crux of the research was what kind of vulnerabilities you're susceptible to if you deploy an MLOps platform in your organization. There have already been some researchers on the cloud, like if you're using these platforms on the cloud, but we wanted to see if you're deploying such a platform in your organization, like in your network, then what kind of security holes are opening up because of that.
I really like the idea of you mentioning that we should treat the models as code.
Yeah.
Where does that idea come from?
That's the thing. So in this research, we discovered and disclosed 20 CVEs across all components. Quite a lot. But the most interesting part of the research is not the implementation vulnerabilities, but rather what kind of inherent vulnerabilities are there when you use machine learning platforms. And one of the most dangerous inherent vulnerability is basically when you work with certain types of machine learning models, they have code execution as a feature. Basically the model allows you to insert code into it. And then when you load the model, you don't have to do anything. You don't have to query it. Just when you load it, then you get code execution. And basically almost everybody I knew from that works a bit with models, they weren't aware of that fact. That's why you need to treat models as code. So because basically if I give you a model and I tell you, hey, like try to work with this model, see what you can. The fact is that once you load this model, I'm running code on your machine. And this can be used in various exploitation scenarios, like client-side attacks, server-side attacks. So that's one of the things we go over on the research. And I guess the scary thing is because it's vulnerability in the format type, there's never going to be a CVE about this because there's nothing to fix. This is the feature. This is the way it works. So there won't be a CVE. There won't be a patch. Either you know about this issue or you don't. And this is only one of the issues that we set out to publish about in this research.
Oh, nice. So if you look at it, it's more or less like PDF files, for example. You have JavaScript, or doc files, or Excel sheets where you have VB scripts. Is it kind of like the same where you have a format for the models where there is a place where you can put code for loading something or preloading or something like that?
Yeah, exactly. Like for example, in Word documents and like various Office documents, you had VBA macro support.
Yes.
Yeah, exactly. So that's kind of the same thing. And people started working with these documents. You would open a document that the macro would just run. There would be no warning and no anything because people weren't aware of the security implication of that because it was new. And this is the point where we're now in machine learning. So right now you load a model and there's no warning, there's no nothing. It just runs. Because this category is so new, people didn't realize yet that you need to put some disclaimer before you run that code. So basically, it's like a very dangerous feature. And right now it's not being really enforced that there should be some interactive disclaimer before you allow it to run. With Word documents, it's already a non-existent attack because, everybody then knew about it and now there's like a prompt. But with machine learning, this is brand new. So now it's only beginning to get abused by attackers.
So what were the other kind of different attacks that you found out in the platforms?
We split it between like inherent vulnerabilities, like I talked about, and implementation vulnerabilities. In the inherent vulnerabilities, we also talk about malicious datasets. So some libraries and services Usually you load a data set and it's like a CSV file, so it's just text. You can't, if you load it, you can't get code execution. But some services actually support formats that when you load them, even as a data set, they will run code on you. So that was the other thing. The third very interesting thing that we found is that a lot of data scientists, they work with Jupyter Lab or Jupyter Notebook, like a tool for running code snippets and seeing the output and then interspersing code with documentation. And what we saw is the output of the code you run, it can be like HTML and it can even be JavaScript. And that JavaScript is unsandboxed. So what that means is if you're running some code snippet and accidentally it generates JavaScript like that you didn't mean to generate, then it has access to the whole environment. And the Jupyter environment, when you control the Jupyter environment, you can run Python code.
Yes.
So what this means, like skipping a bit forward, but what this means that every XSS attack, when it's done in a Jupyter environment, it becomes full remote code execution.
Yes.
So that was one of the biggest surprises for us, actually. Pretty alarming, I would say, because usually there's XSS and you're saying, oh, okay, it runs in the browser, it's not that bad. But now every XSS is a remote code execution. So we actually saw how to mitigate that. We released an open source plugin that mitigates it. It will work for most scenarios, not 100% of the scenarios, but that was really a really interesting finding as well. And basically it means, again, that every XSS is a potential RCE in this space.
So was it given a CVE for Jupyter or?
Yeah, so great question. So this is, again, the way that Jupyter works. So they wouldn't address it as a CVE because it's not an implementation issue. They meant it to be that way. So, and that's exactly part of my point, because it's an inherent vulnerability, it will probably never get fixed. You won't be able to detect it. Like either you know about it or you don't. So we really set out to show people what they should know about when working with these platforms. We also found a few implementation vulnerabilities, like I said, about 20 actually. And basically we did research on the 6 most popular open source MLOps platforms. And then from all the CVEs that we found, we tried to understand what are the 3 top categories of CVEs that will affect MLOps platforms. So this is the other thing that we're talking about there.
Can you give some details of?
Yeah, of course. So the 3 top categories that we saw is first container breakout. So MLOps platforms actually allow you or allow the users of the platforms, even with low privileges, as a side attack, they allow you to run code. One example is, let's say I have permissions to upload a machine learning model to an inference server, which just means I can upload a model and then other users can query the model, like ChatGPT. They can ask questions and get answers. But because, like we discussed before, that every model potentially has code inside it, if I upload a model, I'm actually running code on the server. And then some of the servers run the model inside a Docker container and some of them don't. The ones that don't, it's immediately, like you hacked the server just by uploading a model. The ones that do, the attacker now needs to put in the payload of the model a container escape attack. So either a CVE or some other special container escape attack. So that's why we saw that container breaks are very critical in this context. And we also we looked at 2 platforms where it's relevant. And in one of them, we saw that you don't even need to exploit a CVE because the way that the architecture of the platform is built, you can just do a container breakout without any CVE. It's due to lack of isolation. If diving a bit more into that, basically when you upload a model to that framework, that model lives inside a Docker container with all the other models that are served by that container. And then because it's in the same Docker container, the malicious model can poison all the other models, or it can even exfiltrate the models to cloud, like the attacker server. And these models are sometimes IP of the company that's worth multi-million dollars for that model. So even without escaping the container, you can do a few interesting attacks. That was only one actually a category, but we have 2 other categories that we found of implementation issues in these platforms.
Okay. Can you briefly touch upon the other 2 points?
So the third category is kind of a meta category, I would say. But what we found out is that these platforms are too immature. So the oldest MLOps platforms that we saw is 5 years old. I think it was MLflow. So, 5 years is not that much time. These platforms haven't gotten enough time to become robust yet. So for example, we looked at the number of CVEs in MLflow that came out, and it was 39 CVEs in the past 2 years. So yeah, it's insane numbers. So it was 15 critical, I think, and like 24 high. And we compared it to a robust DevOps component like Jenkins. And in Jenkins, it was about 9. 9 CVEs, it was 2 critical and 7 high severity. So what we expect is just that there will be a lot of CVEs in the upcoming years in these MLOps platforms just because they're immature. So that was another category, sort of a meta category. Maybe actually the most interesting ones was lack of authentication. So we saw a lot of MLOps platforms they do not have built-in authentication, or they do some sort of halfway authentication. And that's also critical because one feature of MLOps platform is an ML pipeline. So that's like just allowing you to write Python code that monitors for dataset changes and then trains the model for you, evaluates it, and deploys it. It's like a DevOps pipeline. It's like CI/CD. Like CI/CD, you might have a commit and then trigger a build, and then the build goes through a test, and then the test goes to production. So ML pipeline is the same thing. It's just that you're looking for a dataset change, and then you're training a model and deploying it. So if you have this feature in your MLOps platform, if someone can control the ML pipeline, it's just they can edit arbitrary code, right? It's just Python code. So if they have permissions, it's code execution as a feature, I like to call it. Because you have permissions to edit the pipeline code, so you can run whatever you want. So now take these two things together. There's a feature that allows you, if you have enough permissions, you can run arbitrary code, but you also don't have any authentication. So actually remote users can just log into the platform and create a new pipeline job and run arbitrary code. And in some of the MLOps platforms, we show it's running inside a container, but in some of them, it's completely uncontained. So it's basically remote code execution as a feature. And we saw a lot of platforms where this is happening. Some of these lack of authentication had CVEs, some of them don't. And then we highlight which ones did and how the industry is looking at it, or actually right now not looking at it. That's what we're trying to highlight, like making people understand that if they're deploying an MLOps platform, they need to look at what features that platform supports and maybe disable some of those features or add authentication themselves externally, like through a, let's say, reverse proxy with authentication, because what's coming built in with the MLOps platform is not enough right now.
Well, this is really scary. But did you for a moment think about, or have this idea that, wait a minute, let me go ahead and check the models in Olama, for example, or Hugging Face for any code execution or code within the model? Yeah,
for sure. So that relates really well, of course, to the first point that models are code. So we checked it, and this is a separate research that we already published. So in our initial check, we found 100 models which were malicious, like really malicious, like had malicious code in them in Hugging Face. Wow. So attackers, attackers are already trying to abuse it.
Yeah.
And we actually found a few variants of the same model, which was the most interesting, that they tried to just pop a connect back shell, like, just hijack your machine basically and pop a shell to like some hard-coded IP address. So like classic, malicious behavior. It didn't say test, it didn't had any disclaimer. It really looked like someone is trying to hijack machines from that model. We actually tried to honeypot it. Like we opened a server with a lot like fake Bitcoin wallets and things like that. And we got a few connections back from the attacker, but they didn't run any interesting commands. So after a while, we let it go. But it was really interesting because we actually saw the attackers connected to it.
Are you planning to release this research as well?
Oh, it's released. That part is already released actually in our blog. That's not something like in specifically now in this research, we're focusing on MLOps platforms, but this previous one was just about how attackers are abusing Hugging Face with malicious models.
That's very interesting. So finally, do you have some advice for either the ML platform developers or users in terms of 3 or 4 or maybe more action items that they can do to at least be protected from what the knowns are?
Yeah, for sure. So first of all, we saw 3 main features which were susceptible to attack in these platforms, which was the ML pipelines, model registry, and model survey. So a key takeaway from our side is to check if your MLOps platform supports these features. And if you're not actively using these features, just disable them. If you do need to use these features, then check that they run inside a Docker, like I said before, and check that your MLOps platforms has a built-in authentication, or add, a reverse proxy to authenticate it. The second takeaway is, again, that because models are code and it drives me crazy that people don't know about it, then you should brief anybody that loads models that if they load an untrusted model, then it's basically code execution. And also you can enforce in your organization only to use model types that don't have this feature. For example, ONNX, PMML, message packs, safe tensors. These are all formats that don't allow for code execution when you load them. So if you use only those formats, you're okay, and you can make a organizational policy to use that. The third thing was just if you use Jupyter, then consider installing our plugin, which sandboxes, it's open source. So it sandboxes and protects you from XSS being RCE, I guess. The fourth thing is just that talk to your CISO and make them understand that if someone takes over your MLOps platform, it could be the same as taking over your domain controller. Maybe I'm exaggerating just a little bit, but it could be in the same scope. Like they could do lateral movement into the whole organization or part of the organization. So just pay more attention to that, because right now everything is breached. Nobody knows that these attacks are possible.
That was an eye-opener. Thank you for joining us.
Sure, my pleasure. Thank you.